All right, so the first thing we'll look at is the homework questions. All right, so let me just choose some. Let me choose, so number 4 on the homework. This brush kind of look at it. All right, so number 4 is a simple one. So right here, you can either decide to divide both sides by 2, or you can multiply the bracket and then, proceed as normal, right? So let me multiply the bracket this time around. All right, so we isolate the 2x by adding 2 to both sides. So this will give me 5/2 plus 2, right? So this, you can view this like this is 2.5. So in my mind, so 2.5 plus 2, 4.5. So you already see the answer popping. But if you're not so keen on that, what you can do is to think of this as 2/1, right? And then you can say, okay, to have this have the same LCM as this, you multiply numerator and denominator by 2, and you end up with 4/2, and then you can just add across. Right? So that's a simple way to work it. But I like the whole 4.5. But if that's not apparent, can do this too. This would be 4/2, and then that will give you 9/2, right? So the same thing. So 9/2. Then you have x. So you divide both sides by 2. This is essentially, multiplying both sides by a half, which you're going to get 9/4. And this gives you 2.25. All right. So that's for that. So multiple ways can work this. So many ways to go about it. And this right here, don't be confused. Some persons, they get confused when they see this. Another way to think of this is, because here I could have just multiplied by a half, right? I could have just said, so I'm gonna rewrite it. When I reach right here, I could have just multiply both sides by a half. And it's the same thing as me dividing both sides by 2. So cancel. And then right here, you'd have 9/4. Good. So let's move right along. The next question. All right, so this one looks good. Let me see, number 5. Number 5 kind of simple, but let me do it nonetheless. So right back the 5x, and then you distribute this 3, it's -3, right? So -3 times x, -3 times -1, +3. This is equal to 39. So this I can simplify, you get 2x plus 3 equal 39, and then subtract 3 from both sides. You have 2x now equal 36. Divide both sides by 2, and then you have x is equal to 18. So that's a straightforward one. The only thing to remember is that the negative times negative is positive. Apart from that, it should be straightforward. All right, let's find number 6 looks interesting. So let's just find some space for that. Everything good so far, guys? Like based on what you see for those who are here?
Yes, sir.
All right. So P minus 1 over 2 minus P minus 2 over 3 equal 1. So for this, you can find an LCM. So that's 6. 20 that goes 3. 20 that goes 2. Notice I arrive at the negative sign here. It comes from negative sign. I bring it down and I put the factor here. All of this equal to 1. Then I can simplify. 3p, and that's minus 3. This is minus 2p. And then here now, plus 4 equal 1. All over 6. I can further simplify. This becomes p, and this becomes, so this is a 3p minus 2p is p, and then minus 3 plus 4 is 1, and that's a positive 1 all over 6 equal 1. From here now, I can get rid of this fraction by multiplying both sides by 6. So 6, right, times 6. This becomes p plus 1 equals 6. And from here, simple stuff, all you do, notice I already subtract 1 from both sides. So now you have p equal 5. So that's another kind of straightforward. Just have to remember to, negative, negative, positive, and just don't make any mistake when I simplify. Okay. All right. So what's another one? I can do number 9. And then number 9. Number 9. So I have 7. 2p plus 1 in brackets. And then minus 4. 3p 3p plus 2 equals 0. So all you have to do now is multiply these out. 14p plus 7. And then this is minus 12p minus 8 equals 0. And then you combine them, right? So 14p. So let me actually show the co-working this time. 7. So this becomes 2p minus 1 is equal to 0. So from here, you add 1 to both sides, right? And then divide both sides by 2. P becomes aha. That one, not too bad as well. So let's go and try. Let me see. And try 13. Right. So I'm gonna fix this up. So we're going to question 13. All right. So for this question, as usual, I group the x terms. So you would, want to get my x terms on the left, so I'm going to subtract x over 15 from both sides. So that would remove the x over 15 from this side. So now you have x over 15 here. So when the multiple steps in this line, and I'm going to add 5 to both sides. So this will remove the 5 from here, and then the 5 would end up over this side. Add 5 to both sides, I get. All right. So this part is simple, that's just 9. So what I can do here, I can do my LCM 15 and I can go through the process. Or I can do a little thing, which is to multiply numerator and denominator by 3 so that I can get the same denominator of 15 that's in this term. So if I go like so, numerator and denominator, I get 3x over 15, x over 15, right? So you can do it irregular LCM where you get the same answer. And now I can simply work out the numerator and keep the denominator. So this now becomes 2x over 15 equal 9. So we have 2x multiply both sides by 15. So 9 times 15. What's that? Guys, you might have to work it out. All right. 15, 9. 9 5s 45. 9 1s 9. And 4, that's 13. All right. So this is just 135. 135. All right. So x is equal to 135 divided by 2. Right? Which is some number. Let me try and see if I can find it. So 2 into this is 6. Remainder 1. And then 2 into 15, 7.
7. So
And then you
67 and a
turn
half.
into 1, right? So you get 67
And a half.
and a half. All right. Good stuff. So let's move right along. If we can go to the one more of these questions and then we'll move to the next topic. I like the color blue. I like this blue. All right, let me see. In the question 15 is probably a good question. Question 15 looks like this. Nine 2x over 3 equals 0. I'm gonna take a sip of the water. So again, LCM, where you get 12, right?
Yes, sir.
And so 4 into that, you get 3 times already.
Mm-hmm.
And then we multiply these out. 36. 8x. What's that? What's nice in the place? All right, so the next move now, we'll group up the like terms. So I'll show a little work in here. This is all over 12. All right. So this becomes 4x. And this is what now? 16, negative 16. No, negative 21. Shana?
Yes, sir. Negative 21. Yes.
Right. So here they multiply both sides by 12 to get rid of this fraction. So 12
Mm-hmm.
here, 12 here. 12's cancel, and of course 0 times anything is 0.
Mm-hmm.
So let me
That
continue
is 0
somewhere up here. So this now is just 4x
minus 21.
minus 21 equals 0.
0. And then I have 4x equals 0.
All right, I'll add 21 to both sides. Then we divide
Negative
both sides
21.
by 4. So this is x is equal to
X. X is
5
equal to 5 and 1 over 4.
over 4. Lovely. All right, so let's move right along.
Mm-hmm.
Good stuff. So
Yeah.
give me about 5 minutes to bring up. Oh, I put it in a group. Let me see if I put it in a group. No, don't look like I put it in a group yet. All right. Give me 5 minutes to bring up something. I've been pause recording. Give me a second. Recording. All right. So the plan is to look at some expanding brackets. So I have been doing it somewhat, but we haven't been as formal as we could be. So this is in preparation for factorization, like simple factorization, not the quadratic type. So let's look at, so let me put, right? So let's expand in brackets. So usually expand and simplify, right? So expand in brackets and
Simplify.
simplify. Or should I say expand brackets and simplify? Either way. So we have been doing types like, it's all right, we have an x here, plus 1, and we distribute it and say that times that. So we have been doing it, right? Or the type that looks like 3, say 3p. Let me put a p and let me put a 3 here too. So we have been doing it, nothing new under the sun. And then this would be what, 9p. And then we have other types now that look a little more interesting, but it's the same concept. This is x to the 3 plus x squared 5 minus 2x. You go again and you multiply these out. Multiply this again, right? So So this is just a quick refresher. So this becomes now 5x squared, and then this is x to the 3 or x cubed, right? And then you simplify where you can simplify. So we see we have a x cubed here and an x cubed here, so minus 2x cubed. So this becomes a minus x cubed plus 5x squared.
Yes, sir.
So we're already familiar, with some of these things already. And we went as far as, I believe, we looked at, but not as a topic by itself, we look at types like these where we say, okay, so you have x plus 1 in bracket, and you have x plus 6. I will expand these, right? I will say
Yes,
we can distribute the terms. So how we do this is to look and say, all right, this times this, and this times this. All right, so it will start there and we'll say, all right, x times x is x squared, x times 6, 6x. And then now we'll look and say we can distribute this.
the one.
1 times x, and then
Yeah.
I will get x plus 6. And then we'll simplify.
So it's x
It become x squared, 7x
7x.
plus 6. So we did that, right? And we say we can do it another way, which was to break out the terms here and multiply them explicitly. And all I mean is to say, from here, you could just go and say x times everything in the second bracket plus 1. So you care about the plus 1, and then times everything in the second bracket. It gives the exact same result. It's the exact same concept, but you're just taking your time, right? And you say, okay,
Okay.
x times this, x times that. Let me even work it one below the other. So comes x squared, 6x, and then it's a 1 times that, 1 times that,
Plus
so
1x.
x, 6. So it's the
Plus
same thing. We're just taking our time.
okay.
Oh, this is 7 plus 6. All right.
Yes, sir.
All right. So what we're going to do is to work some of these a little more, see if we can find more complicated ones. All right. Let's get a little practice. I may just leave you guys to do a couple just to get a little practice, and then we'll move on.
Okay, sir.
Right. So let me do. All right. Let me put some on the I guess I'm gonna call it board, and I'm gonna ask you. So let's say we have 6n plus 1, 4n minus 2. So work that real quick and we'll go through it together. So I'm going to put another one. So you just work it out and tell me your answer. So I'm going to put another one right here. Maybe I can put it, the line right here. So. And then another one I can put is another one. Right. So do those and let me know. Giving you a couple minutes. So maybe I can pause. All right, so we're back. So what you have for us now? Let's answer for this one.
For the first one, I got 16n minus 2 for the answer. Shift my right.
Sure.
4. I'm rechecking,
Sir,
sir.
I
Rechecking.
got 41 in minus 2.
Rechecking, sir.
We get something different.
6n. So that's 6 for 24n minus 12n plus 4n minus 2. 12n minus 12n. 24 minus 12 equals 12n. Mm-hmm.
All right, let us check
So
out.
let's work it.
So I'm going to do it the simple way, which is to break this out, right? And to show the multiplication, where I said 6n times 4n minus 2 plus 1. So this is the one here, multiply by 4n minus
N.
2. So
Yes, sir.
6n times 4n, that is
24
24n
n.
squared. Mhm.
Oh, yes, sir. I left off the squares.
That is squared. And then 6n times minus 2 is
Minus
12n.
12n.
Then we'll go again. So this one's simple now. This one times everything. So you get back the same thing, right?
4n.
And then now
Yes, sir.
we simplify. So we put the 24n squared. And then this becomes
Mm-hmm.
8n.
Minus. Mm-hmm. Ah,
So you
that's
get
where I mixed up. I found out where I went from.
all right. So is it that you're going to need time to check but these two?
Yes, sir.
All right. So let me give you guys some time. So I'm going to pause again. All right. So start again. So what you guys get for this one?
All right, so I got 15x squared minus 58 plus 48 minus, hold on, 15x squared minus 58x plus 48.
All right. Let us see. So if I break it up, that's all right. So this is 15x squared. Um, this becomes a 40x. This is 18x, and this is positive 48.
Yes, sir.
All right.
15x squared minus
So
58x. Good.
all right. Good stuff. So what about this one? What you got?
I got 12a squared minus 35a plus 25.
All right. Let's see. So we have 12a squared, and this is our 20a, and this is 15a plus 25. Space kind of small, but we work with it. So this is 12a squared minus 35. Let's go a little to the right. 35a plus 25. Lovely. All right, let me give you guys some more. Let me give you guys like probably 3 more, and then we can move on to a different kind of expansion. All right, so you can try this p minus 2q p plus p plus 2q. That's one type. Then we go to another one. 2a plus b minus c. Let's try another one. Let's try, yeah, that kind of look not so straight. I'll try. Let's try 5x minus 6y 2x minus 3y. All right, so try those three and we see how it looks. Okay, so I can pause it. I'll give you 5 minutes. All right, so let's go through these. So what do you get for the answer?
All right, sir, for the answer, I got p square,
Mhm.
p square minus, all right, minus 4q squared. Right, the second one. Show me the on the right track, this one.
Yeah, that does sound like it. Let's see. So P times the second bracket and minus Q times the second bracket. So this becomes P squared. So later on you'll learn about difference of two squares, but we just work it out like we never know anything about it. So we go again, this is 2PQ or 2QP, don't really matter.
Yes, minus
And then this is minus 2. I'm going to write that as PQ to match with that. And then this is minus 4Q squared. So the middle piece cancel out.
Yes, sir.
And you just end up with P squared
Minus
minus 4Q squared.
What?
Nice. All right, so let us see if we can do this one. What you got for it?
I got 4a square minus 2ac plus 2ab minus bc.
Wow, a lot of different stuff. All right, let us see. So 2a times the second bracket and then plus b times the second bracket. So this becomes 4a squared 2ac plus 2ab minus bc. Therefore minus bc. And when you look, I don't say anything that can cancel, so we call it a day.
Yes, sir.
All right. So what about this one? What you got?
5xy minus 12xy minus 18y.
Let's put in here now square.
Sir, I got 10x square
Hmm.
minus 27xy plus 18y square.
All right, let us see. Let us check that out. So if you take your time and you say, all right, 5x times what is in the second bracket, and then we'll go again and say minus 6y times what is in the second bracket. So I have 5x times 2x, that's 10x squared. So you can't, don't make that mistake. Always put on your square or so I get the entire thing wrong because you can simplify the wrong thing, right? So this now becomes 15, negative 15xy. Then you come here now, this becomes 12xy. That's minus 12xy. And then this is positive 18y squared. Always put on your square. So now we have 10x squared. This simplify now and give you what? Like 27, negative 27xy plus 18y squared. You guys see that? You guys see it? Yes, no, maybe so.
Yes, sir.
All right.
So, right. 10x minus 27xy. Mm-hmm. Good.
All right. So You guys want more questions? Or are you getting comfortable already? Or we can move on. What you guys want? More questions? Probably can give you two more. I'll give you two more. All right. So let me see over here. Okay. Something interesting. All right, nothing is that interesting, but anyway. So let me give you another one like this. 5x plus 2, 5x minus 2. And then let me give you some more of them. And let me give you so these I want you to note very carefully, right? When you get the answer, when you look at the answers for them, when you look at this, look at the answer, and see if you see any pattern, right? So I'm going to give you guys some time to work it out. All right, so before we start these questions, let me add this last one here. If I can put it further down. Okay. So try this one as well. A plus B, B minus B. And then we'll start working the question. So with that last one, we'll come back. All right, so what you guys got for this one?
15x squared plus 6x.
Repeat.
15x squared plus 6x.
But this one?
5x with the
That sounds very weird. Where said the answer is?
I got 25x
15x.
squared minus 4.
Yeah, that
So I
sounds
got
good.
25x squared minus 4.
Mm. So let us go through because we need to make sure we clarify that because we don't want persons to be getting it wrong. No, right? Because after this, I'm moving on to a slightly different kind of expansion. So I'm going to go through slowly, right? So we say we look here at these two terms and we're multiplying them one at a time with a bracket over here, the second bracket. So we say 5x multiply this bracket here, and then this term now, second one plus 2, and multiply this again, right? So we see that the 5x is from here, and we see that the plus 2 comes here, and these are just the second bracket, right? So we have 5x times 5x, that's 25x squared. We have 5x times minus 2, that's 10x. Then now we reach over here, this is 2 times 5x, that's 10x. And then have 2 times negative 2 is negative 4. Now we see that the terms in the middle cancel. This is minus 10x plus 10x, that gone to 0. So you get 25x squared minus 4. And we'll finish. All right? So let us move on to this one. What you guys got for this?
X squared minus 1.
X squared minus 1. Anybody else? Same thing?
Yes, sir. That's what I got. Yes,
All right.
sir.
So go again. So x, and then we put the terms in this bracket, and then plus 1 multiply with the second bracket again. So theta, this is here, plus 1 is here, and of course we have the second bracket. So x times x is x squared, x times minus 1 minus x. This is plus x minus 1. Middle term, again, cancel out, we get x squared minus 1. What about this one? What you guys got for this over here? The third one.
X squared minus 16.
X squared minus 16, all right. So we'll go again. And then we'll have and then this becomes middle cancel out. I'll get this. All right. So this one at the bottom now, what you guys get?
So I got a square minus b square.
A squared minus b squared. So a is a times a minus b, and this is plus b times a minus b. So we have a squared, ab, ab, b squared. Middle terms cancel, a squared minus b squared. All right. So after doing all of those questions, anybody can come to some conclusion about questions like these, this type here, that we working now, or we have been working. So these 4 questions in a pattern.
Yes, sir. All of them, the answers having squares. The first part of the answer, you end up with a square. And then at the end, you normally end up with a single digit or a double digit.
All right. Anything about the single digit or double digit? Anything?
They're always negative. They're
All
always in the negative.
right. Good observation. Any other observation? I'm saying in all cases, there's no middle term. It's just 2 terms to end up with. Right? Always 2 will get 25x squared will get minus 4. Unlike the ones above where, you know, sometimes we'll have something in the middle. Like this had minus 27xy, this had minus 2ac. This we don't have any middle term, just 2 terms, right? Anything else? And what about this number here? Anything special about it? We'll have another question like it up top here. Let me show you. We have one left here, see here. Say it had a minus and a plus. So we'll get something here.
Okay.
All right. So the next thing I want you guys to notice is that the terms in the brackets are basically the same. You just want to have a plus sign
and a negative.
And this one have a negative sign. But it's the same 2 terms. Just one with a plus, one with a negative. And then this down here, in a sense, generalize it. Because it have A and B, see there? And the only thing different.
Yes, sir.
Plus and minus. So it's telling you that whenever you have a situation like this, the answer is just A squared minus B squared. So for argument's sake, if I was to make up something and put, say, x plus 2, x minus 2, then the answer is just, so if I think of this as my A and think of this as my B.
X squared minus 4.
X squared minus 4, right? Or if I want, I can think of it this way, x squared, put it like this, then you know that.
Go to this 2 square. Okay.
Right? So I want you guys to notice that relationship. It becomes very important when you're factorizing and in essence you're moving from here to here. So when you reach there, you'll see. But remember, when you have a situation like this, it comes to something like this, and we call it a difference of two squares, right? So this is a difference sign,
Okay.
and these are the two squares. So a square minus b square. And when you reverse engineer it, if you're asked to factorize it, you'll go from this direction, go upstairs where you expand it out to be a plus b in bracket then a minus b. All right. All right. So let's move right along. Let me see if I can find some space. Change the color. All right. Suppose we give you questions like these now and say expand and simplify these, and I give some look like. I give you that, and I give you. So I give you. Oh, all right then. So just work them at the same time. If you know how to work them, you can work them. If not, I'll work the first three, and then you guys can work the last three, right? So let me go again. And then over here can be 5x plus 9. All right. Anybody have any idea how to work these?
Yes, sir. You can put back x plus 1. Say I square the x plus 1, say just so the answer is going to be x squared plus 1.
No, I know.
No.
All right. So what does square mean?
You're going to multiply the same thing by the same. Are you going to put an x1, x
Yeah.
plus 1 there,
So then have x plus 1,
plus x plus 1?
all square.
Right. So
Okay.
this means this.
All right
So
then.
I will know how to work this already.
Mhm.
Okay.
Yeah, x squared plus 1, the one,
What?
the one.
Right. So it becomes x squared plus x plus 1, which is x squared plus 2x plus 1. Right. So that's our word that. So again, you write out what 2x plus 1 square mean. It means you multiply the thing by itself. So we know to work this already, which is just and this becomes 4x squared plus 2x plus 2x plus 1.
So it's 4x squared plus 4x plus 1.
All right. And then again, 2x minus 5. We'll go through again. Oh, this is minus, my bad. Minus 5. 2x minus 5. This becomes 4x squared, 10x minus 10x plus 25, which is 4x squared minus 20x plus 25. All right, so we'll kind of catch up things a bit, but you guys, I'm sure can see.
Yes, sir.
All right, so try these three now. Right, so I'll pause and then come back. What you guys got for this one? The first one.
9x.
Hmm?
9x squared plus 24x plus 16.
All right. That sound like it. Anybody else?
Yes, sir, got the same thing.
Okay. I mean, carry this down a little. So, as usual, and then we know how to do this already, you know? So this is just a nice little walk in the park. Look, I'm not gonna make this thing too long, you know, and take up too much space. All right, give me a second. I'm gonna catch it up here soon. So this becomes 3x. All right. So 9x squared, 12x, 12x plus 16. So 9x squared, 24x plus 16. Lovely. What about this one?
All right. For that one, sir, I got 36x squared minus 12x plus 1.
All right. So we go 6x minus 1. And then we'll go through nice and smooth. So this is 36x squared, 6x, 6x plus 1, 36 squared, 12x plus 1. Nice. But the third one, I want to show you guys something. Let me say, kind of look big. Maybe I can't show you. Let me try though. So the answer, without even thinking too much about it, I'm gonna say it is 25x squared. 5 9 45 times 290
Plus 81.
Plus
x
81.
plus 81.
Yes, sir.
Right. Now you guys might say, oh, sir, how you know that? What you do? So if if you were to generalize this and say, okay, what is a plus b squared? A plus b squared and work it out as, all right, let us go through the long way. So it's a plus b, a plus b. Now it's all right, a and then b, and then we say, all right, we get a squared, we get ab, we get ab, and we get b squared. So this now becomes a squared 2ab plus b squared, right? So because I know this, right? It's something that, you know, we get familiar with. A teacher teach you, and then because they work questions so often, it kind of, I guess, and get ingrained in the mind. So when I see this now, I'm like, all I need to do. So if you think of this as A, let me change the color. If you think of 5x as A, then you know that for your final answer, you should have a square. Now, a square, right? So if you think of it, let me show you. If you think of it like that, so this becomes 25x squared. So I know that if I were to think of 5x or substitute 5x into A, right here, and then it becomes 5x squared, right? All in bracket, which is now 25x squared. And then I know how the rest of it goes. It says that whatever I see here, if this is my b, then the next term going to be 2 times 5x times 9. So when I look and I say, okay, 5 times 9, 45 times 2 is 90. So I said, okay, the middle term is to multiply these two and then finally times it by 2. So see it there? So, and then the last term now is just this squared. So I know, so okay, it says plus 9 is up, and then I just square the 9. 9 is 81. Right? And then, you know, so all of this is happening mentally, right? Become 90x 81. So, you know, the general solution or the general expression. And then if you know that, then literally you can look at anything and expand it out. So for example, if I say, okay, x 5 squared, so I know that, okay, it's supposed to be x squared, then 2 times x times 5, that is 10x. And then the last one, I just need to square the last term, which is 25. And I know the answer, right? Just like that, I finish. So the thing about this though, it takes practice. So if you're not going to practice, like doing this and looking at it and writing it out and confirming that, you know, your answer is correct and all of these things, then you stick to what you know, right? If you're comfortable with doing it the long way, or, you know, then you stick to what you know. You know, because the worst thing you want to happen is that because you try like a shortcut fancy stuff, you go get the question wrong, right? Now, this is helpful when you're doing like multiple choice, you kind of boom, go through it real quick. But as I say, work it the way that you're most comfortable, because the aim is to get it right. Cool. Of course, in paper two, I would probably show the working, right?
Yes, sir.
Yeah, so paper two show the working.
Okay.
All right, so let's move along. Anybody have any questions before we move? Because we're done with the expanding bracket now. I think we,
Sir, I'm good with that now.
okay, we'll leave it on it. So, so I'm going to look at some simple factorization now. And then I suppose can close off the day. Some simple factorization. Change the color. So I call it simple, like in comparison to quadratic factorization, right? So we're not going to factorize quadratic expression in this class, maybe the next class. So we're just looking at some simple stuff, right? So with factorization, it's good to understand HCF and the highest common factor. You know, remember when we were doing fractions, I'll look at LCM, lowest common multiple. You know, I guess I can give you guys an idea what I mean, right? So usually you're asked to factorize something that look like this, for example. Take it. So this is a simple one, right? And so factorize. And so, all right, you know, you may come like this. And then we say, okay, 4a minus 2. But it's a sir, what just something, you know, you must use 3 and whatever and thing like that. Cool. Notice that 3 times 4a gave about the 12a, and 3 times minus 2 gave about the 6. But why 3? Right? You know, but then when I look at this is even wrong. A better number would be 6, right? So this is still correct in terms of, yeah, you were able to take out 3 and equality is the same, but you know, why not use, for example, why not use 2? You could say, all right, so let me use 2 and see what happens. And you know, this equality would hold, you still be right, but in terms of factoring now, when somebody says factorize, they're expecting that you use the highest common factor on the outside, like so. So when you look at 12 and you look at 6, 6 can go into itself and 6 can go into 12, right? And then this becomes 2a minus 1. So this is what we're looking for when we say factorize. Cool? But we still not really explain the process the real and proper way. So when you look at 12 and you look at 6, and you are to list the factors of 12 and 6. So we know 1, 2, 3, 4, 6, 12. 1, 2, 3, 6. Well, anytime I say this, it's just a joy. This is I think they call it a perfect number because the proper factors are proper divisors. When you add them up, you get the number itself, right? So you're not gonna hear nobody tell you that. But just an interesting fact. So let me take off the highlight, right? Now, when you look at this, you see that, okay, you have a lot of factors that are common. And this factor, a lot of common factors. But the highest common factor is 6. Now, you may say, but sir, this come at the end. All right, let me give another example. Let me give probably 12 and 8. 12 and 8. Let me say 12 and 8 work out. Say it was 12 and 8. So we know how 12 set up. All right, let me put 8 down here. We'll have 1, 2, 4, and 8. Now, if you were to ask for the highest common factor between 12 and 8.
4.
4, right? So we're looking at, all right, boom, 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 4, 4. And that's really it. You look at the highest factor that is common to both of the terms that you're factorizing. So in this case, we have 12 and 6. What's the highest common factor between the two of them? 6. But it could have been that the question is 12a minus 8. And the highest common factor between the two of them would be, as I said, 4. So it would be, we were asked to factorize this, this would just be 4 into 3a minus 2, right? No, and of course it has to be equal, you know, because you're just extracting the highest common factor. So there should never be a case when you factorize and when you try and multiply it out back, you can't get back the original expression. You know, something went horribly wrong somewhere, right? So you must be able to get back the original expression. So that's really it. And then you have sometimes you have variables, like you would have, say I have t, say I have t square, and I have, let me put t square and t. In this case, the highest common factor, whoa,
T.
it'll be t, right? Because t can go in a t square, and t can go in itself. But if you use something else, it's not gonna quite work out. Maybe that one too easy. Let me try another one. Say you have m mp square, mp and say you have, yeah, let me just leave it there. I'll probably put M. Now, if I put M, you look at these three and say, okay, what is the highest common factor among the three of them? Right?
M.
It would be M because M can go in itself, M can go in an MP square, M can go in an MP. However, if there was no M, there was no M and it was just these two,
Would be MP.
that it would be MP, right? Because MP can go in itself, MP can go in an MP square, but MP square can't go in a MP without leaving something, some kind of remainder, right? So it's like that. So the more you practice it, you see the point. Of course, I could I could spend half an hour just fleshing out these different variable things and say, okay, we're gonna have that variable, what's the highest common factor. But I figure more or less you guys would have seen this before. It's just to refresh your memory as to what is going on, right? So I'll work some question. I will say that it's not rocket science. It's just practice, right? And I'll go through and take my time to make sure that you understand what I'm doing, right? So I'll go through. All right. So if you have, say you have 4x squared minus 8x, and I said to factorize this, what would be the highest common factor? All right, let me answer another question. If this was just 4, so let's ignore the x squared and the x. So what's the highest common factor between 4 and 8?
4.
4.
Yeah, 4. Nice. So that would just be 4. Now, we're asking now, what's the highest common factor between x squared and x?
X.
X. Lovely. And then now it's just for you to fill in the rest. So 4x times what gives 4x squared? X. 4x times x give 4x squared. Says, all right, we know that's supposed to be in there. So, and then you can go again and say, okay, what going to give me 8x a minus 2, right? So 4x times x, 4x squared, and 4x times minus 2 is 8x, right? And that's it. You would have,
Okay.
yeah, simple as that. Sometimes it's difficult. Some persons find it difficult to come up with these numbers. And all I would say is that if you can find this number, then if you're not spotting it so fast, then you can say, all right, but no say 4. So I'm looking on 4 and 8, I know say 4 the highest. Highest common factor, I know say between x squared and x, I know say x are the highest common factor. But the brain just not quite get this as it. So what you can do is to say, all right, we know say 4x are the highest common factor. Let me just divide the terms then by 4x and see what I get. So it's okay, 4 of them cancel x, one of the x them cancel. See, we get an x. And then you go again and say, all right, the next term minus 8x, and I divide it by 4. So I'm going to cancel now, right? I get a minus 2. So see there, I get x, which belongs here, and I get the minus 2. Now, you're going to have to, if you're here and this is how you get it, you're going to have to graduate from this very quickly because there's no time for you to be doing this on paper. This should be done in your head, right? So if as I say, you have to just graduate quickly, and the quickest way to graduate from doing it this way is to just practice. The more you practice, the more you see how the numbers relate, and you can make the connection faster. So let us do another one, right? Um, let's do another one. What about 6x plus 24. So again, that's the highest common factor. For the numbers is just, let me even put it below. So it's just 6. 6 can go in itself, 6 can go in at 24. So
Yes,
6.
sir.
What about x, right? And so there's no other variable here, right? So x get left because although x can go in at this term, x can go in at this term. So you just leave with 6. So have 6x
Plus 4.
yeah, and that's it.
Okay.
Yeah, it's simple, right? Let us try another one. Let us try something. Let us try 100x minus 40. When you look at this, it's all right. Like 10 can go into these two. Don't leave in
Yes, sir.
remainder. But
A
we
remainder.
ask you another question. What about 20?
Yes, sir.
20. All right.
Yes, sir.
So it's all right. 20x
So enough.
minus 2.
20x.
All right. But this need a number, you realize? It's supposed to be.
The x would need a number.
So this need to be. So this is 20 times
Times
5x
4x. 5x. Yes, sir.
minus 2.
5x
All right.
minus 2.
All right. So, but suppose, just suppose, right? Suppose we didn't pick up the 20. For whatever reason, we just never see it. I would say, all right,
We use 10
we just put 10. I would say, all right, we use 10, and then
times 10 times
we get 10x
10x
minus 4.
minus.
Then we look
Yes,
on
sir.
this now, something supposed to ring off and I say, but wait, we're not supposed
Still
to
not simplified.
we're not supposed to factor this some more. When you look at 10 and 4, right? So you're going to say, all right, let me factor it again. So this time it's a 10, and you look on this, you see that you can factor out a 2. So 2, and then this becomes 5x minus 2, which this now out here, 2 times 10, you get a 20. So you get back the answer up here, right?
Yes,
So
sir.
all is not lost if you didn't come up with the highest common factor at first. Because I don't know. Maybe you just need some more practice or whatever the case may be to get a good ranking. But you should be able to spot that you can factorize some more and come down to the answer. Right?
Yes, sir.
All right. Let us find some space in the place. All right. So we have some space. All right. Let me see if I can. 500. All right. So what next? Another example. What about 20? All right, let me see if I can go further though. Give me a second to find this thing. All right. So let's say we'll have 27x minus 33. We'll look again what can we use for this?
3.
3, all right? So we say 3 out here. What goes inside now?
9x
9x, because 3 nines 27
minus 11
minus 11. And we're done. So good stuff. So Yeah, we have some questions that we can try. I'm going to give you guys to try. Um, oh, wait, before I give you guys some, let us do something a little more interesting, and then I'll give you guys a try. It's a little more interesting, a little bit more. Let me see. What about something that looks like this? 5x squared plus x, and even say 5n squared minus 10n. Right? So this is no. And then another one, oh, this is a 10n. Then another one says 16x squared plus 24x plus 24x. So this one, what you guys think? Hmm? When you look at the numbers, right? You can think of it 5, and you think of this as 1x. 5 and
So
then
one
that's a 1. So
would
you're not gonna put it in a, but a 1. Now what about x squared and x? What has come on?
would be x.
Just x,
X.
right? So 1x, but we're not gonna put 1, and then
Just have
everything is
x open bracket 5x
5x.
plus x.
Sure. What's supposed to come here? So
No. 5x so that x will be x squared. No. 0
no,
or 1?
1. So we get 1.
1.
So x
Oh,
times
yeah.
5x is 5x squared. X times 1 is x.
That's
All
1.
done. All right. So let us try this one. When it comes to the numbers now, what's the highest common factor?
5.
All right. When it comes to the variable now, what's that?
N.
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 5n. Let me fix that properly.
N.
Right. So
Minus
5n.
2n. N.
So I'll put in
Open
that.
bracket. N minus 2n.
N minus 2n. You sure?
2n.
If you put n right, I say 5n times 2, and going to get 10n squared. So that's
Oh, just 2.
just 2.
2.
Yeah. So 2 would be enough. So let me put the bracket a little closer. All right, what about this?
4.
So 4 is, you're sure? Any
4x. 4x.
all right, we're gonna use a 4x and see what happens. Go put
Could
in
use 8. No. So we could use 8 too,
8. So 8, that's what I was looking for.
Mm-hmm.
So
Could use 8
so 8 is the
higher.
number. But I use a
So it's
4x because
8x.
I know that eventually we would see we could factorize further, and at that point,
Okay.
yeah. So 8x.
So it's 8x.
Mm-hmm.
2x. In the
2x
bracket, you'll have 2x plus 3.
plus 3. Nice. So that would give you the answer. Right? So anybody have any questions? Want to work more of these before I give you the questions to work out? Or you guys would like to try me?
I would like to try some.
All right. Let me see if I can just put this across here. Guys, cancel the screen.
Yes, sir.
All right. So I want you guys to do from G to O. So number 5, G to O. Let me make that a little bigger. G to O. I'm saying number 5. Number 2. number 2, J to O. And then now, I want you guys to do number 4. And I guess I can say J to O as well. Say how J to O. Well, you don't have to do. We do this one already. We do 27. We do this one already. So fine. Okay, you don't have to do about that one. So
J
J,
to N to
J
N.
to N, and then J to O for here. And I would like to see what you guys do with number 3, just to see. So this would be, I want you guys to, I'm a matter of fact, I want you guys to do all of 3. This way you have your brain really thinking, you know? This is, um, and you know, it's not hard, just, it's the same concept. It's just that they put some questions in, and I want to see how, if it discombobulated, you know, if it make you do anything different. So as I said before, it's a J to N for 2, all of 3, and then for 4, J to O. So I'm gonna leave this up,
Okay, sir.
I'm gonna pause it, give you guys about 20 minutes, and then we'll come back. All right, so the first one is, there's a J, so
J.
which is 50.
15 minus 40x.
All right, what's the answer for that?
Sorry, I wrote 10 open bracket 5 minus 4x.
All right, that's done, correct. Next one is K. What's the answer for that? Well, not
6
answer,
open
write it
bracket
6
first.
bracket minus
Write it first.
x man.
Yeah, yeah, next one is 5. Hey, you guys get that?
Mhm. Yes, sir.
All right, K, and then L. L is 5y. That's 45. That's the answer.
5 bracket y minus 9.
All right, then M. M is 12 plus 36x. What's the answer?
1 plus
No.
3x.
What's the answer?
1 plus 3x.
All right,
Mhm.
go on. So I have, where am I gone?
16x plus
Oh, that
32
one 16x. So
plus
10.
32.
What's the answer?
So
X plus
16x plus 2. 16 open bracket x plus 2.
All right,
Good.
everybody get those?
Yes, sir. Good
All
so
right,
far.
all right, let us go now to 3. So 3, I have a little thing where they, oh, wait, just like that. All right, so then put a question sign here. So what should that question sign be? What should be there?
For the question side, sir, x.
X should be there. Great. So let me just put question sign is equal to X. All right. What about the next one is, oh, B. So this is A, this is B. They have X squared plus 2X. And then they have another question sign, X plus 2. What should the question sign be?
X.
in
X. All right, so that's simple. What about C 2A squared, 5A. Then I have question sign 2A minus 5.
A.
So A, correct? And the B, 4x squared plus x equal x. And then they have question sign plus question sign. So I have two question signs. So I'm going to call this question sign 1 and question sign 2, just to differentiate them.
Sorry. 4x plus 1.
plus
So 4x plus 1.
Yes,
Everybody
sir.
agree? All right. So question sign 1 is 4, and
Mm-hmm.
question sign 2 is 1.
1.
Oh, so it's supposed to be 4x, I mean. So this is 4x.
Yes, sir.
All right. So E. E, where is E? E to have x squared plus 4x equal, and they say x question sign, I went for question sign 1, question sign 2. All right, so this is
X,
what's going on.
x plus
X plus 4.
So we're saying the first question sign is,
X.
oh, this is supposed to be 1. The first question sign is x. The second question sign is
4. 4.
4. All right. Everybody agree so far?
Yes, sir. Good so
F.
far.
So F now. So x a plus x b, and this is x question sign. Question sign. So the first one is what?
A plus B.
plus b
A plus b. Oh, as in
Yes.
A for this. Okay,
Yes. And then B.
and then B. All right. So G. So going through. G is 3x, and then this is question sign. So what about this?
The
2x
first question sign 2x plus 1.
So it's 2x,
2x plus
and then 1.
1.
yeah, 2x plus 1.
Is everybody good at that?
Good so far.
All right. So this is the last one now for question 3, where x squared is 2ax. And then for the resume the recording, right? Oh, good. Um, this is 2x, and I have question sign minus. So I'm
Yes,
gonna have
sir.
1 and 2.
2x minus
Minus
1a.
So it's a
2x
2
minus a
minus 1.
1a.
All right, or a, we can call it a, right?
Mm-hmm.
So question sign, so a. All right. So we'll finish off with that. So now to go to question. So question 4. Question 4 now it's a J to O. So J is
30x squared.
30x squared minus 18x. What's that?
6x
6x.
3
Hmm?
6x bracket 5x minus 3.
All right. Everybody agree with that?
Yes, sir.
All right. Let me get this out of the way. So the next one, J, then K, 5, 5 plus 5, n squared. What's the answer for that?
5 open
Bracket
bracket
1
1
plus
plus
1n
5n
squared.
You sure?
plus 1n.
That means square, right?
Plus n squared. Yeah.
So
Yeah,
J,
n.
K,
N
L.
square. Yes, sir.
All right, what's the answer?
5 bracket 2n squared minus 3.
Say it
Oh,
again.
yep.
5
5.
bracket 2n squared minus 3.
Okay. Everybody agree?
Yes, sir.
All right. So we're getting there. So we're at M now. So 3n squared, 9n. What's the answer here?
3n bracket n square plus 3
There's a 3n, then
bracket
Mm-hmm.
n.
n square.
No, man. If you have 3
Sir,
n,
look
right?
back.
So
No, sir, look back on it. Isn't it 3n square? 3n to the third power?
Yeah, that's what I'm saying.
oh, it's to the third power.
3n
My bad, my bad.
Yes,
yeah,
sir.
plus
Oh,
Is to
3n
the
bracket
third power.
2n
All
square.
right, so this is what? N
plus
squared
3. Yes,
Yes, plus
sir.
3.
plus 3. All right, good,
Yes,
Yeah.
good
sir.
observation. All right, next one is
9x square.
what's the answer?
That's
9.
9x square, open bracket, 1x minus 3.
Okay, I have 9x bracket x minus 3.
Come on, same thing.
It's
Okay.
a 9x open bracket
Yes. X
X
minus
minus
3.
x minus 3.
3.
Okay.
Okay, it can be 9x 1 minus 3 too. It can be that.
Say it again.
Normally it wouldn't be minus 1.
No,
Yes.
man, I have 9x
Mm-hmm.
bracket x minus 3, but I heard someone say like 9x square 1 minus 3. It can be that too.
You're not hearing so good. You say if it can be.
The answer can be 9x square bracket 1 minus 3.
No, no, this couldn't work.
No.
Oh, because I heard this, I was wondering if it could work that way too.
Oh
That's not
my,
what I have, but I heard this answer. So I was wondering if it could be
oh
possible.
my,
It
two
can work that
different somebody.
way. Okay, okay. Then.
Yeah. All right. So the next one, I think, yeah, the last one is
Mm-hmm.
10x
X
cubed.
to the third power cube.
The answer is 1.
So it's
5x
5x,
square.
open bracket, 2x
5x square.
square.
Oh,
The 5x
I
square,
have 5,
what's that?
No, sir.
5x
5x.
square.
You
This
sure?
is third.
No, sir. It should be 5x, open bracket, 2x square minus x.
Okay, let's
Wait
see
a
what I
second,
have.
wait
I
a
have 5.
second, wait a second. Between the x cube and the x square, what's the highest common factor between them?
Between the
Let's
two
just put
numerals, would have 5.
So for the numbers, it's 5, but what about the variable?
5
Between the
would be
x cube and the x square, what's the highest common factor?
x.
No, man, it's x squared.
No, x square.
Mhm.
Okay.
Yeah, so x squared can go into x cube, right? When
Mm-hmm.
it goes in, it don't leave any remainder per se, it leaves another factor of x. So if you go like this, so the other
Mm-hmm.
factor it goes in and it leaves a clean factor of
Gives you x.
right?
Okay.
Yeah.
so what's the answer, sir? I have 5x square bracket 2x minus 1.
Yeah.
Okay.
Okay.
All right. So just remember, it's similar to over here. So here we're well, I guess because this had a cube. If this had a square, so if this was 3n cubed plus 9 square, then it would have been answer would have been 3n square. Then it would be
Mm-hmm.
1, not 1, would be n, then
Mm-hmm.
plus 3. All right. So if
Okay.
this question had a square on it, then for the variables, is n square would be the highest common factor, and then the number now you put 3, and then you get 3n squared times n plus 3. You
Okay.
can add that to the list. All right, so we are through today. We will pick up with more factorization. We'll have to factorize quadratic expression, and we want to see if we can do that and change the subject of formula, that topic, changing the subject of the formula, and those should be good for next week. So what I'll do, there are some other factorization, like the factoring by pairs, and that kind of warm you up for factoring quadratic expressions So I'll send those videos to warm you guys up. Hopefully, you watched the video that I sent last week. You guys watched it?
Yes, sir.
All right. So that will definitely show up come next week. So that video and the factoring videos, we'll build on that. Monday, I would like to do something Monday, but I do see the entire class here. As in, I do want to say Monday, and then I see out of the three persons here now, I see one person turn up.
They'll be
Sorry, I
available
have a
Monday.
class. I have a class on Monday from 5 to 7.
You have a class on Monday?
Oh,
Yes, not with this institution.
Oh, okay, okay.
oh.
Yes,
All right, so
I'm
I'll
we'll
be
trying to.
available though.